Hello, this is Mr. Henry, and thank you for coming back to the second part of this incredibly long and fairly challenging lesson. So here we are in example 5, and what we're talking about is the product of a power, power of a product and power of a quotient properties. Now, I'll be honest with you, we've actually been doing this first property for a little while, so make it this one very easy. This is the property where I was talking about distributing this outside exponent by all of the inside exponents. So I could say that this is 5 to the first power, 4 to the first power, and if I multiply that together, I would get 5 cubed and 4 cubed. Now, maybe you thought, hey, Mr. Henry, can you just take 5 times 4 and get 20 and then take that cubed? Yeah, these actually have the same value. So 20 to the power of 3 is 8,000. 5 cubed times by 4 cubed is also 8,000. These are equivalent. But this is the property that I'm trying to show or reinforce in this part of the lesson. Okay, here's the letter B. I'm going to take the outside exponent times by all of the inside exponents. I'm going to kind of like distribute. Now, this t, you don't see the power, which means there is one of them. Now you see it. Now you multiply. So this becomes s to the 24th power times t to the power. And that's it. So we have been doing this. We did this quite a bit in the previous video, the first half of this lesson. So if you could please try these two problems right now, and when you're ready to continue, hit play, and we'll go through them together. Okay, so here, I'm not going to multiply this. This is wrong, because this inside here is just a number 1.8. That's not two separate things. Okay, what I'm going to be doing is this 1.8 is just there to kind of keep it separate a little bit. You can probably even get rid of those parentheses and just make it 1.8 squared times by 9.4. It just helps keep everything a little separate, and then that would all be to the 4th power. So the math you're doing is you're taking the outside exponent times by the inside exponent. So the first one is going to be 1.8 to the power of 4 times 2 is 8. And the second one is going to be 9.4 to the power of, well, the exponent on the 9.4 is a 1. When you multiply your exponents together, 4 times 1 is 4. That's as much as we can do. Letter D. Multiply the exponent, multiply the exponent, multiply the exponent, multiply the exponent. Every piece that's being multiplied together has their own exponent. If you don't see it, throw your 1 in there. Then go to town on this thing. So this becomes now 3 to the power of 4. 4 times 1. M to the power of 4 times 5. 20. N to the power of 4 times 3 is 12. P to the power of 4 times 1 is 4. And I'm just doing a quick check. They all have different bases, which means I cannot add anything together. I cannot multiply anything together, simplify. So that problem is actually done. Okay, so this is that distributing of your exponents property. Now, we've seen problems similar to this in the past that we left the fraction alone. And I said we were going to come to a time where we're not going to leave them alone. And this is that time. So there are situations where it is a good idea to actually distribute this outside exponent to the pieces on the inside of a fraction. So for example, this s has a power of 1, and this t has a power of 1. And what I'm going to do is I'm going to take this outside exponent and distribute him to the top and to the bottom of my fraction. So this then becomes s to the 4th power over t to the 4th power. And that's done. That's as far as I can go for this one. That's simplified. I can't cancel anything because they have different bases. This is an S, and this is a T. So that would be done. Letter F, it might not seem like you understand why we're doing this, but it's just to show the property here. I'm going to multiply the outside exponent by the inside exponents, and since these guys can't see the exponents, they're both 1. So this becomes then 3 to the third power over to the third power, which if you wanted to go through and actually simplify and evaluate, this would become 27 over 256 times 8 times 8, 8 to the third power, 512. And using our handy dandy calculator, we could even check to make sure that this and that are actually the same thing. So I take, in parentheses, 3 fraction 8 to the third power says, okay, nice big ugly decimal, right? And then if I take this guy and change it to a decimal, I'm going to divide 27 divided by 512. Same thing. Look at that. So these two are equivalent. They are the same thing. They have the same value. They're just written a different way. This one's written with powers and exponents. This one is not. Okay. Here is letters G and H. Go ahead and try them both right now. I pause the video, try them out. When you're ready to continue, hit play, and we'll go through them together. Okay, so letter G. Distributed exponents. This guy has an exponent of 1. This guy has an exponent of 1, which makes this 4 to the 4th power divided by 9 to the 4th power, which you could actually say is done right there. You maybe wanted to put it as a fraction. Sure, it's still done. We still can't combine anything else because they have different bases. Okay, that was the easier one. This one's a little bit trickier. So when I take my outside exponent and I multiply by all the inside exponents, I'm going to take him times by that exponent, him times by that one, him times by that one. So the two up top, the 3 and the y, they both have an exponent of 1. So this becomes 3 to the 4th power, y to the 4th power, multiplied by exponents. Down below, that becomes x to the 8th power. And that's as much as I can do. They all have different bases, 3yx, which means I cannot do any canceling. I cannot combine anything else together. That was a terrible square. Example 6. So this property, or these last two properties here, are understanding negative and 0 exponents. 0 exponents are very easy. Negative exponents are, let's just say they're less easy. So a 0 exponent, if there is a trick, a rule, a thing to remember in your brain about anything to the power of 0, it is that anything to the power of 0 will always equal 1. Always. Check it out. 6 caret 0. 6 to the power of 0 is 1. 9 caret 1. Negative 3.56 caret 0. Negative 1. The reason why I did that is it counts the negative out front separate from the number. If I put it inside the parentheses like this, negative 3.56, in parentheses, then caret 0, now it knows the negatives on the inside of the parentheses. Okay, so it's just the calculator has some quirks in how you input numbers into it. But essentially, anything to the power of 0 is 1, no matter what it is. And a way that helps us, and the way that we kind of use that, is an example like letter B here. This guy here is equal to 1. Now, if I would rewrite this just slightly, what is 5 cubed times by 1? The answer should be 5 cubed. Anything times by 1 is itself. So really what we end up doing most of the time, if you have something to the power of 0, a lot of times, in my mind, I just go like this. I just scribble him out. I ignore him because I don't need to take 5/3 times by 1. I'm going to get the exact same answer. It's like saying plus 0. Well, yeah, plus 0 is not doing anything. Okay? So once I've eliminated that 5 to the power of 0, once he's gone, anything that's left I can just now clean up. 5 to the 3rd power, 5 squared. I'm going to cancel 2 of these. I'm going to cancel 2 of those. These are all gone. I'm left with 1 up top. And that gives me 5 to the 1st power. Anything to the power of 0 is 1. Okay, go ahead, pause the video. Try these two problems. You should find them to be on the relatively easier side. When you're ready to continue, hit play, and we'll go through them together. All right, so letter C. Hopefully you took and you started by combining these together. These on the top. So 4 cubed and 4 to the 6th combined together to give you 4 to the 9th power on top. You also have a 4 to the 9th power on the bottom. And when you subtract here, you're going to cancel these. So you cancel out 9 of those. You cancel out 9 of those. There's none on the bottom. There's none on the top. You're going, well, what the heck is left over? Well, think about this. If you got 4 to the power of 0 up top, you're left with just the answer of 1. Maybe that doesn't make sense to you. Okay, let's try this another way. Here. You have 4 to the 9th over 4 to the 9th. You have a number divided by itself. What is a number divided by itself equaling? 1. Yeah, it's 1. Okay. If you took this and you did the old subtraction method we talked about before, this is 4 to the 9 minus 9th power. I don't really like this method, but it shows the point here a little bit better. You do get 4 to the power of 0, which again equals 1. So there's about 3 different ways I can show you why this is equal to 1. Letter D. This junk is equal to 1. And since it's going to be 1 times by this stuff, I really don't even need him. He's just useless garbage in this problem. Over here, though, well, there's nothing left to do. That's just 2.5 to the 3rd power. I can't combine him with anything. There's no other terms. There's no other expressions. There's nothing else, no other parts for him to combine to. So he's done. And now we get to negative exponents. So here is the rule for negative exponents. The rule for negative exponents is to make a negative exponent a positive exponent, you switch which side of the fraction, numerator or denominator, that piece is on. So here, I'm going to take this whole thing and I'm going to put it over 1. I'm going to make this a fraction. To take a negative exponent and make him a positive exponent, we're going to switch what side of the fraction he's on. So if he is negative up top, if I move this piece to the denominator, he becomes positive. This becomes 8 to the 3rd power over 8 to the 3rd power, which we just saw in the previous example is equal to 1. Something divided by itself is equal to 1. You could also say, hey, you know what? If I add these two powers together right here, I have 8 to the 3 plus negative 3 gives me 8 to the power of 0, which is equal to 1. And maybe you're questioning how you go, but what would happen if I moved this piece to the denominator? Well, if he's positive on the top, then he's negative on the bottom. Anytime you switch a piece from one side of the fraction to the other, it changes the sign of the exponent. Okay, so letter F here. I have three pieces. I've got a to the negative first, b to the negative second, c to the positive fifth. I need for this piece and this piece to have positive exponents. So since he has a negative exponent, I'm going to move him up. So he's going to become an a to the positive first power on the top. Just erase it and write it again. A to the positive first power. He is going to go to the denominator. Since he's negative on the top, he'll become positive in the denominator. B to the positive second power. And that c, he's already positive. We don't need to mess with him or touch him at all, so he is going to stay where he is. And that's actually done. There's nothing else I combine. My A's, B's, C's, my bases are all different. I cannot combine anything. Here the bases were the same, so I knew I had to simplify farther. The bases are all different, A, B, C, so we are done here. Go ahead, pause the video, copy these two problems down, try them out. When you're ready to continue, hit play, and we'll go through them together. Okay, so I see I have a negative exponent. To turn a negative exponent to a positive exponent, you switch what side of the fraction it's on. So now I'm going to have this x from down here, which by the way is x to the first power, and I'm going to have this x from up top. But what is left on the top part of the fraction? There has to be something there. Answer is it's a 1. It's kind of like our ghost 1. You know how if we had like the number 5, and say if we would turn that into a fraction, we'd put it like over 1. That ghost 1 is always there. Well, here there's kind of like invisible times by 1. That's always there. So if you move this piece to the denominator, now it's his time to shine, and he gets to actually come out. So we had to have something up top. It's a 1. It's not going to be a 0. If it's 0, this whole thing is going to equal 0. And that's not going to work out. Now, I have two x's on the denominator. They can be combined together. Since they're two powers being multiplied together, I'm going to add my exponents, giving me x to the third power. Letter H. I have 8 divided by 8 to the negative fourth power. This has a negative exponent, so to make him positive, I'm going to move him to the top. So this becomes 8 and 8 to the negative fourth. Remember that this guy has no, you don't see the power, so it's 1. Oopsie. He's no longer negative up top. He needs to be positive. That was the whole point of moving him to the top. Is to no longer be negative. He's going to be positive. And down below, well, we actually have that ghost 1 now. We actually don't even need to put over 1 here because everything's on the numerator of the fraction. Everything's on the top of the fraction, so we could even just go, you know what, I don't need him. And then when we take and we combine our powers together, two powers being multiplied together, we add the exponents, gives me 8 to the fifth power. Haven't done one of these in a while, so let's check it quickly. 8 divided by, I'm going to put this in together. I don't even know if I can do that. Of this, I'm going to do, I'll try it. 8 divided by, I'm going to put in parentheses, 8 caret 4. Okay. And if I put in 8 caret 5, 8 to the fifth power, go. We got the same answer. Proof that this is equivalent to that. We got the same answer. Our answer and the beginning problem have the same value. If you try that and you get a different value, it means one of two things. Either you messed up typing in the calculator, or your final answer is wrong. Okay? This is a combination. These next, however many problems we're going to do, 12 problems or so, is a combination of all 4 properties in one. Okay, so we have to know positives and powers and exponents and everything, all 4 of the properties we've learned about in the previous video and this video to solve and simplify these expressions. And yeah, expressions should be with only positive exponents. Write your answers in exponential notation. Yeah. All right, so here we go. I see parentheses, which means I'm going to distribute my exponents. So this becomes then 6 to the negative 8th power times by 6 to the 3rd power. There's a few ways you can go from here. You can combine these exponents together first and then worry about the negative, or you can worry about the negative first and then can combine or cancel the exponents. I like to worry about the negative first. So I'm going to take and make this whole thing a fraction. And then I'm going to move this piece. Let me go back to ghost mode. I'm going to move this piece to the denominator. I'm going to turn this 6 to the negative 8th power into a positive 8. So I have that. Now, when I start canceling 6s, I have 3 6s up top and 8 6s on the bottom. So when I cancel, I can only cancel 3 up top, and I can only cancel 3 on the bottom. So what's left over? I'm left with 5 6s in the denominator, and there is nothing left up top. 6 to the 5th in the denominator, and I can't put a 0. It's a 1. This is what you would do if you got rid of the negative first. If you got rid of the negative second, if you combined these 2 powers together, if you took 6 to the negative 8th plus 6 to the 3rd, and you combined your exponents, you get 6 to the negative 5th power. Negative 8 plus 3 is negative 5. And then to make this guy have a positive exponent, you'd move him to the denominator. We get the same answer. Letter B is trying to trick you. It's trying to make you think hard when you really don't have to here, because this power of 0, this whole thing is to the power of 0, which means this whole thing is equal to 1. Now, if you didn't see that, maybe you went like this, and that gives you 3 to the power of 0, m to the power of 0, that's equal to 1, that's equal to 1, it still equals 1. So final answer, 1. Anything to the power of 0 is equal to 1. Letter C, nice and easy actually. Good for us. Okay, so that is 3 to the 4th power over 3 squared. So I see these guys have the same base. And I'm going to start canceling out exponents. So if I cancel 2 here, they're gone. If I cancel 2 here, I have 2 left up top. Now, I guess we've learned this part now, so I can be a little more specific. When I cancel these 2 here, I have 0 3s on the bottom. So technically, I have 3 to the power of 0 and 3 to the power of 2. And since we know anything to the power of 0 is equal to 1, we kind of do this. And we don't really need this thing being divided by 1. It's like a ghost 1, right? 3 squared divided by 1 is still just 3 squared. So that's why usually when I had this and this completely canceled out, I just kind of erased the whole thing and we skipped from this step to that step. There is an in-between step that I've just been kind of skipping here. This is 3 squared. 3 to the 4th divided by 3 squared is 3 squared. Okay, one for you to try. Go ahead and pause the video, try it on your own right now. When you're ready to continue, hit play and we'll go through it together. Alright, so did you distribute your exponents? Did you distribute your exponents to everything? Every piece here has an exponent of 1. So now this becomes 2 to the 4th power, m to the 4th power over 6 to the 4th power, n to the 4th power. And actually, I can't really do much more than that. I could theoretically do this math and divide this, but it's set up here to, your answer should be an exponential notation. And so I'm going to leave the exponents here. There is a possibility that if you're doing a test and you don't see this answer, it's possible you might have to take 2 to the 4th power and find out what that is. And then take 6 to the 4th power, find out what that is, and then multiply or divide those to get your final answer. But here, we didn't really need to. Okay, this page has 2 more for me and 2 more for you. So I'm going to take this and I'm going to write it as a fraction. I don't really like this division symbol. I like it like this. Okay, now first thing I see is there's no parentheses, so I'm not going to be doing any of the distributing of the exponents, but I do have a negative exponent I'm going to worry about. So this m is to the negative 2nd power. The 3 is not. The 3 has an exponent of positive 1. This m has a negative 2nd power, so I'm going to move him to the top to cancel out that negative exponent. So what's going to be left is 9m squared. These 2 pieces stay up top, joined by this guy. Down below, I have 3. Now, I can do 2 things here. I can actually do this math. That's very simple. And I can do this math. That's very simple. So 9 divided by 3 is just 3 on the top, so there's nothing else on the bottom. And m times by m squared is m to the 3rd power. Remember, this is m to the 1st power, m to the 2nd power, combined together gives me m to the 3rd. Letter F. I am going to, well, distribute my exponents. I have parentheses. I'm going to distribute here and distribute here. That gives me 4 to the power of 0, still, over 4 to the power of 12, times by 4 to the 5th power. Now, I'm going to go ahead and I'm going to fix the top of this, because I know anything to the power of 0 is equal to 1. And now, since I got rid of those, I multiplied that exponent, I actually don't even need these parentheses anymore. That's just going to make the problem a little confusing. So what can I do from here? Well, this 4 to the 5th power, in case you don't know, if we write it as a fraction, like this. And hopefully you remember some of your fraction math on how we would simplify this expression. So what we would do is, when you're multiplying 2 fractions, you multiply across the top. 1 times by 4/5 is 4/5. You multiply across the bottom. 4 to the 12th times by 1 is 4 to the 12th. And then you simplify your fraction. So we're going to simplify. So here, I got 5 4s on the top, 12 4s on the bottom. So if I cancel out 5 of these, I have none left up top. If I cancel out 5 of these, I have 7 left at the bottom. So my simplified answer is 4 to the power of 0 is 1. 4 to the power of 7 is, well, 4 to the power of 7. Okay, here are 2 for you to try. Break them down 1 piece at a time. Go ahead and pause the video, try them on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so letter G here. First thing I see, there's no parentheses, but I do have a negative down here. So I'm going to go ahead and move him to the top. So if I rewrite the problem, I'm going to have 5 times by x cubed times by x squared times by y to the 4th. So I moved him kind of like right in here over y squared. Okay, now from here, I'm going to combine what I can. I see I've got 2 x's that can combine. I've got 2 y's that can combine. This 5, though, he's just going to come along for the ride. So there's my 5 times by x cubed times by x squared. Since they're being multiplied together, I'm going to add the exponents. Y to the 4th divided by y squared. Since they're being divided, I'm going to subtract the exponents. So if I cancel 2 here, there's 0 of them. If I subtract 2 here, there's still 2 left. I would have a y to the 0 power on the bottom, which just equals 1. I'd have a 1 on the bottom of my fraction. Up top, I would still have y squared. And we really don't need this over 1. It's not hurting anything, but it's kind of useless information. So this would be my final answer. Letter H. I'm going to distribute to get rid of my parentheses. Distribute these exponents and those exponents. This guy, since you don't see it, has an exponent of 1. This becomes 6 squared. K to the 6th times by 3 times k to the negative 8th. Now, I'm going to go ahead and I'm going to erase this k to the negative 8th because I didn't actually see this negative exponent before, but I'm going to move him to the denominator of the fraction. So I'm going to erase him here. And as I move him to the denominator, he is the only thing, oh, he's no longer negative, he's the only thing in the denominator of the fraction. Okay, now I can look for anything I can combine. I can combine those two because they have the same base. So, and actually I'm also going to move this 3 up front. 6 squared times by 3 times by, okay, let's do my k's here. So if I cancel out 6 of these and 6 of these, there are 0 k's on the top, there is 2 k's on the bottom. That means this k to the power of 0 is just equal to 1, which essentially cancels out. Down here, that k squared needs to stay k squared. And I suppose if you choose to do so, you could actually simplify the top a little bit. 6 squared is 36. 36 times by 3. It's not that terribly ugly. 108. I don't know if this is better or if that is better. They're equivalent. Okay, 1 more for me, 3 more for you, and then we move on to multiple choice, and then I think we're about done, or at least close to it. Simplify. I see a negative exponent. Now, the negative exponent is on this whole thing, from here to here. So this whole piece needs to go to the denominator. So I'm going to rewrite this as 21 m to the 4th h cubed over 3h. Okay, so I have 21 m to the 4th over h cubed over 3h. So I'm going to look for what can I do. Since I don't have any parentheses, I don't have any more negatives, I have some h's here. And actually I have my coefficients, my numbers in front here. That can be simplified a little bit. So what's that going to give us? Well, up front, 21 divided by 3 is 7. Top. I have m to the 4th, who's not really doing anything, so he just comes along for the ride. Now my h's. I've got 3 h's up top, 1 h down below. So if I cancel out this one and one of these, I still have 2 up top and none down below. So I would have h squared on the top. And now, when I divided by fractions, this 3 kind of disappeared. This 21 over 3 changed into a 7 on the top. Here, this h to the power of 0 would just equal 1. So I would have technically an over 1 on the bottom, which you don't need. You don't need to have something over 1. That's just extra information. Makes the problem look a little bit uglier. So there's my final answer. I only have 1 of each base. They cannot be combined together, so that problem is done. Oopsie. here are the last 3 of this type for you to do. So if you could, please pause the video, try them on your own. When you are ready to continue, hit play, and we will go through them together. Alright, so let's see what we got here. I don't see any parentheses, I don't see any negatives, so I'm just going to start combining stuff together, I guess. So I'm going to actually start by separating out a little bit. I'm going to make sure I know what everything is. So this is 3 to the first power, w to the first power, w to the 7th, w to the 5th, 9 to the first power, w to the first power. Now, it might be helpful if we just, since this is 2 fractions being multiplied together, if we multiply across the top, multiply across the bottom, and then simplify our fraction, it'd make it a little bit easier. We'd have 1 fraction to deal with instead of 2 separate fractions. So let's do that. I'm going to multiply across the top. So I'm going to write this as 3 times w to the 7th over, I'm going to move the 9 out front. Usually put the coefficient out front. 9 times w to the 5th times by w to the 1st. Okay, so since I was multiplying 2 fractions together, I wrote it as this fraction times this fraction. Now I can combine this. And heck, there's a ton of stuff we can combine here. I can combine across the top and bottom. I can combine top and bottom. So I guess you just got to decide how it is that you want to do it. And my method may not be the same as your method, and that's okay. But I do see that when I combine my the 3 and the 9, when I simplify this fraction, I'm going to have a 3 in the denominator. So I'm going to combine across the bottom here. I'm going to combine these. That's going to give me w to the 6th power. 5 plus 1 is 6. This is going to give me w to the 8th power. 1 plus 7 is 8. And then if I now combine these together, if I cancel out 6 here and I cancel out 6 here, I have 0 on the bottom, 2 up top. And since there's no other w's on the bottom, those are canceled out. This actually is our final answer. The 3 and the 9 simplified to give me 3 in on the denominator. All of these w's, there's 8 w's up top, 6 w's on the bottom. When they canceled out, I'm left with 2 w's on the top. Okay, letter K. I'm going to go ahead and throw him away. He is equal to 1, so I don't even need him. That was 1.4 to the power of 0. Just there to make the problem uglier. That's all his whole job was in this case. So he's not needed at all. So I'm left with, if I simplify, 3b to the 4th power. Now I'm going to get rid of my parentheses by distributing these exponents. And these both, since you don't see the exponents, have an exponent of 1. So this becomes 3 to the 4th, b to the 4th. That one was much easier, much quicker. I'm going to start letter L by writing this as a fraction. Again, I don't like that division symbol, so this to me says 4d to the 4th all squared over 2d squared all to the 4th. Okay, so what are we going to do from here? Well, first thing I'm going to do is I'm going to get rid of those parentheses. I'm going to distribute my exponents inside. So this becomes 4 squared d to the 8th over 2 to the 4th d to the 8th. All right. Parentheses are gone. There's no negatives to worry about. So now I start worrying about combining my similar bases. So I've got some similar bases here. And actually, if you look at them, they're the same. D to the 8th over D to the 8th. Those two things are going to cancel each other out. They're both going to cancel. That's going to equal 1. So this is essentially gone. So I have now 4 squared over 2 to the 4th, and I don't know if that would be the required final answer or if I should actually simplify and find the numbers. I mean, 4 squared is 16, 2 to the 4th is 16, that equals 1. So my final answer, this thing here, is just equal to 1. Would probably be an acceptable answer. Problem solving. Get away from some of those ugly problems for a little bit. It says here to arrange the exponential expressions in order from least to greatest. Okay. So we got to find which ones are the smallest and the whole way up to the largest of them. So if I evaluate, I can see, I know that 5 to the 3rd power is 125. That's 5 times 5 times 5. That's 5 cubed. Back when we were talking about cube rooting and perfect cubes, that's what that is. This, if I would simplify by multiplying my exponents, I get 5 to the negative 6th power. Calculator me. 5 to the negative 6th power is going to be a very small number. Look at that. There's 4 zeros in front. So 0.1234 64, right? Yeah. That is awfully darn tiny. Third one here. You could do one of two ways. You could multiply 5 times 2 first and get 10 and then exponent, or you can exponent and then multiply. I'm going to multiply first. I'm going to take 5 times 2 and get 10 to the negative 4th power, and I'm just going to type that into the calculator. 10 caret negative 4 equals 3 zeros, 0.0001. Awfully tiny. That's easy. So when I multiply my exponents, that gives me a power of 0. 8 times 0 is 0, so anything to the power of 0 is equal to 1. And finally, 9/8 squared. You could do one of two ways. You could probably just type that straight into the calculator if you're trying to find it as a decimal. I would do fraction, or with parentheses, 9 fraction 8 squared. And maybe you don't know what that is as a decimal. You can divide it, or if your calculator has a fraction to decimal button, because these calculators are different enough in that feature, I'm just going to divide. I'm not going to take 81 divided by 64. 81 divided 64 equals 1.27. Rounding. Which actually is honestly good enough because we just need to figure out the order from least to greatest. So out of these, well, they're all positive. The smallest of them would be the one that, it's not this one, or that one. It has to be one of these two guys that start with a 0 point something. This guy is 0.1234 zeros. This only has 3 zeros. So this is actually smaller. This is 64, let me see. Tens, hundreds, thousands, 10,000s, 100,000s. This is 64 millionths, which is the smallest of them. Remember, as you're putting stuff in order from least to greatest, always go back to the original form of the number. This is 1 tens, hundreds, thousands, 1/10,000ths. That is bigger than 64 millionths. So 5 times by 2 to the negative power. Okay, now I've got 125, 1.27. So 1 is bigger. And then we've got 1.27 is the next. And then finally, 5 cubed is the largest. Letter B says match each exponential expression on the left with the equivalent expression on the right. So if you simplify all of these, something on the left will match with something on the right. So how about this? To save us a little bit of time, I'm going to go ahead and simplify the ones on the left. The ones in blue on the right, I'm going to have you simplify, and then we're going to go through the rest together. Okay, so I'm going to simplify here. This is going to give me, if I multiply my exponents together, that's 2 to the third power times by m to the 12th. This cannot simplify at all. This is 2 squared m squared when I multiply my exponents times by m to the 8th, which then can simplify down to 2 squared times m to the, these guys combined together to give me m to the 10th. And over here we have 4 times m cubed over m to the 9th. These m's can be combined. If I cancel 3 on the top and 3 on the bottom, I'm left with 6 left on the bottom. 6 m's on the bottom. And my 4 still up top. Now, these aren't 100% completely simplified, but that should at least get you started. So I want you to simplify the ones on the right that you can, and then match up what matches up. Go ahead and pause the video and finish this problem up. When you're ready to continue, hit play, and we'll go through it together. All right, so without even doing any work, you probably saw that's a match. You probably saw thought there was another one, but maybe not. Okay. Now here, this 2 cubed, 2 to the third power, 2 times 2 times 2 is 8. You probably saw the power of m to the power of 12, m to the power of 12th, and took a good guess. Same here, m to the power of 10th, m to the power of 10th, you took a good guess. 2 squared is 4. And then you probably determined that the only thing left here is probably the match there. It's worth taking a second or so just to simplify over here, though, just to make sure we're right. I'm going to start by distributing my exponents. Give me 2 cubed m to the 9th over 2 to the 1st m to the 6th. I can see that the m's will combine together and the 2's will combine together. When the 2's combine together, I get 2 squared on the top, because one of these cancel and one of these cancel, leaving 2 up top. I can see 6 of these cancel, 6 of these cancel, dealing me m to the third power up top. And 2 squared, 2 times 2 is 4. And so we do get to this same 4m cubed. Last of these problems, I think. Maybe? Yeah, last problem. Which exponential expression below could not have a value of 16 when h equals 4? So I'm to understand that when h is equal to 4, all of these will have a value of 16 except for one problem. So we have to decide which of these would not have a value of 4. So I'm looking around here, and I'm going to definitely do A and B first because those two problems look the easiest. B looks the absolute easiest to me to figure out. So if I try this here, 4 over 2, the 4th power. If that does not have a value of 16, I'm done. I don't have to do the rest of them. So let's see. That's 4 divided by 2 is 2. 2 to the 4th power is 16. Shucks. I'm trying to find which one does not have a value of 16, and that one did. Okay, letter A is the next easiest one for me to try. So if I plug in 4 to the 8th power over 4 squared squared. That's 4 to the 8th. I'm going to do the exponent on the bottom here. So if I multiply my exponents together, giving me 4 to the 4th power. And if I cancel here and here, that gives me, if I cancel 4 of these, I have none left. If I cancel 4 of these, I have 4 left. So 4 to the 4th power over 1. And 4 to the 4th power is 64. I think I find myself an answer. Now, I guess for sake of completeness, I'll check the other two as well. But I'm pretty sure letter A is the answer. I don't know. Maybe I made a mistake and maybe there's two answers. 2 times 4 squared times by 4 to the negative 1st power. So first thing I'm going to do is I'm going to do two things. I'm going to distribute my exponents, and I'm going to move him to the bottom of the fraction. So this would simplify down to 2 squared times by 4 squared over 4. And this math, 2 squared is 4. I'm actually just doing the math now. So 2 times 2 is 4. 4 times 4 is 16 divided by 4. Let's see. Clear. 4 times 16 divided by 4. Oh, that guy has a value of 16, so he is not what I'm looking for. Letter D. If I plug in 4 for H. Okay, so that gives me, if I do the exponents and negative at the same time, I'm going to distribute the exponents and I'm going to move him up top. That gives me 4 to the power of 6 over, oh, actually not over anything, because when he comes up top, he's going to become 4 squared. And let's see. 4 to the power of 6 times 4, that gives me 4 to the power of 8, which is way too big. So 4 caret 8 is a huge number. 65536. Which does not work out. So I guess in this problem, actually, there was 2 of them that did not give me a value of 16 when h equals 4. Both A and D did not work out. Summary. Let's finish this lesson. Summary for this lesson. In your own words, describe how to turn a power that has a negative exponent into a power with a positive exponent. So how do you get rid of a negative exponent in your own words? Okay, so you can do that, answer that question on your own. This has been lesson 1.1. Thank you for watching.